part of a large-scale group which is being sponsored by the Tata Foundation in India. We're working in Gujarat in the city of Bhuj, which had a devastating earthquake some years ago. A number of buildings were damaged or destroyed. So one of my colleagues, John Oxendorfer, is working with me, and he's looking at earthquake-resistant structural systems, which again are inexpensive, which could be used for inexpensive homes. Another architect is working with us designing what would a plan for a neighborhood look like, which would include some of these kinds of things. So the idea is to come up with an overall design scheme that people can use, again, for low-income housing for people, which is affordable, which is comfortable, and which is safe, which they can use in these particular areas. We've done some work in China along the same lines, and the hope is a lot of the research we have will be useful in other parts of the world. There's a number of benefits. We did some earlier work in northern Pakistan with, again, low-cost insulation systems in schools. And the schools we worked on had no insulation and were so cold in the winter they had to close them down. The children couldn't have education for 2 or 3 months out of the year because they were just too cold to be in these buildings. So again, just the application of an inexpensive kind of insulation system could change essentially the educational program in that particular part of the world. In almost all the developing world, people are obviously trying to improve their standard of living. And the idea is if we can help them do it in a way which is sustainable, which a way doesn't require substantial use of materials and energy, particularly materials which then require energy in their manufacture, we can in fact improve their standard of living, which is what they want, and at the same time help provide for the future sustainability of the world. And the hope is we get them interested and useful for natural ventilation. As they move up into, say, the middle class, they'll be more amenable to that kind of technology to use it in that way as well. We've done research in aerogel, and we certainly are not the first people who have done it. It has been done by, and there is in fact a industrial product which is available, although it's quite expensive. The idea in my work, and this is some joint work I did with Lorna Gibson, who's a faculty member in material science, and the idea there was to develop a aerogel panel which could use as a retrofit insulation. One of the biggest problems in the developed world is we have a huge number of buildings which have already been built. And if we look in the future, if we're going to really do things to reduce energy in the built environment, we have to talk about retrofitting existing buildings. The hardest problem when you retrofit is how do you retrofit a building for added insulation? In a 2x4 construction, you can blow insulation, but a lot of masonry construction, you can't do that. So the idea is to use aerogel so that we can have a reasonably good insulating value and develop basically a wall panel, which might be a ½ inch thick, which would provide insulation. So it would almost look like the paneling you use on the interior of your home and would provide added insulating values. So I was worrying about how do we optimize the insulating value. Lorna Gibson was worried about the mechanical properties because aerogel is a very, very light material, has very little strength. So the idea is how do you develop a panel which is structurally sound, which is essentially the bones, if you will, of this panel, which holds it together and provides the strength, and then we would fill it with the aerogel insulation to do that. This was some work we did jointly, sponsored by one of the large chemical companies. They have done some economic studies, and frankly, at this stage of the game, they're still not enthusiastic. The economics may not be there yet to use this in practice. But I think we've made some strides as far as some of the things we need to overcome if you wanted to use aerogel for those purposes.